What's up guys, this is Ronnie. Welcome back to our channel Total Technology. This is tutorial 4 and today's topic will be on some exception or one of the most important exceptions on Numpy array. So till now we have only seen how to create Numpy array, how to get the size and shape of your array, and how to build those intuition towards the structure of the Numpy array. But in this tutorial we'll be going to talk about some very important exceptions. So this is not about only the exceptions or error. Actually these are the some sort of thumb rule for using Numpy array data structure. So ultimately we are going to deal with numbers or datas or huge numbers when you are going to start working on your data science or machine learning project. So if you are not clear about those exceptions, it will give you some sort of difficulties to understand. So most of the guides or data science tutorial or algorithm, these rules are not written because they assume that you already knew this exceptions or rule. So I thought of creating this tutorial to give you guys very very detailed understanding of this exception. So just follow along with me very carefully and try to understand the concepts very deeply, or else it will be really difficult for you to work with the Numpy arrays in the future. Okay, so let me go to the slide. So first slide is that no divide by zero error. So no divide by zero errors, it is purely mathematical thing. So in our mathematics we all know that if you are trying to divide some number using zero, we'll get some sort of error, that divide by zero error. This is normal thing. Okay, and also those are already familiar with some sort of or can remember their high school mathematics. They also know we cannot remember anything with zero. It's defined that it's infinite, but again it's undefined. Okay, something infinity means undefined, which is in programming language we often get divide by zero error. Okay, so we'll see this thing from Numpy. Okay, so let me first import Numpy as np. Okay, and after that let me just create one array, np dot array, like this, 1 2 and 3. Okay, so a is this. Now I'll try to divide a with 0. Okay, like this. See, I'm not getting any error, rather I just get this thing and the answer is this. Okay, but if I do this thing in normal Python, let's say I have a number 10, b10. Okay, now I want to divide b by 0, we'll get divide by 0 error. See, division by 0 error. Okay, so this is one of the most important thing or thumb rule for Numpy array. So in our data science or Python project, if you are assuming that if you are going to get division by 0 error, it is not going to be happen. Okay, so rather you will get infinite. Okay, so this is one of the very important thing, and also you have to remember. So let me just write this thing here. And no division by 0 error in normal Python, we will get division by 0 error. Okay, so that's it. We'll go to the next chapter, next slide, which is Nan values. So this is again one of the very important things. So what I'll do, I will just put everything here. So let me run this thing. What happened? Okay, so let me remove everything here. So no division. I'm just doing it because after this tutorial I'll be going to upload this notebook in my GitHub repository, so whenever you guys are going to watch this video, you can easily refer to this thing. So that I'm just going to make the comment over here, no division by 0 error. Okay, and after that Nan values. Okay, so I need to write something. Nan means we'll write, but before that, suppose I'm creating another array, np.array, and the values are 1, 0 and 100. Okay, 100, and we'll try to put this here, and we try to divide this by 0. Okay, just now remember this thing, in divide by 0 will not get any error, rather will get infinite. Here we got the infinite, but here something unique will happen now. See this thing, see, we get infinite for this element, we get infinite for this element, but we got a Nan value for this thing. So when you are going to do something 0 divided by 0, it is undefined. In Python Numpy, it is represented as Nan. Nan means something undefined. Okay, means this is a number or whatever which is undefined. Nan, it is undefined, not equal to anything, even Nan, even not equal to Nan. So Nan means something undefined. Okay, so in data science we often represent Nan for missing values. Suppose you have a data set, and in the data set you are having 1000 attributes, and for the 1000 attributes, few of the data sets the attribute number 1 and 10 is missing. That time, to represent the missing values, we use Nan. It means something undefined which is not known and which is missing. Just to represent missing or undefined values in machine learning or data science, we use Nan values. And just because we are going to deal with numpys everywhere in data science and Python, so this is very important and very unique thing to understand what is the value is getting represented by your data sets when you are going to apply Nan. So just remember one thing, Nan means undefined and which cannot be equal to anything. Okay, if you are trying to compare this thing with another Nan values, it will give you false. So I'll just prove my point over here. So let me, okay, why this is my YouTube link is coming. Okay, so here suppose np.nan is a value is equals to np.nan. See, it will return false. See, it is going to return false. So now the main question is that how will justify that this is a Nan value or not. Okay, so justify that Numpy supports one function or provides one function. So we often will use this function in Numpy. So it is called np.isNan. Okay, is used to check Nan values. Okay, so this is the basic properties of Nan. So what I'll do, I will just put it here. Okay, I will create this thing again. Okay, so what I'll do, and it will return with this thing. So I'm just doing it to give you guys what do you say, like reference. Like definitely you guys will forget these things when you are going to watch this video after 2 days or 3 days or 1 week. So that time it will be very difficult to understand until and unless you're not having some sort of reference. So that is, I'm just creating this PDF, but don't worry, I will again separately upload the GitHub the Jupyter notebook into my GitHub repository. Okay, so now you understand what is nan and how to find this nan thing. Now we can create np.is nan, and inside that if you put np.nan, see it will return true. Okay, so I will write here. Okay, fine. Okay, so now we have seen what is nan. Okay, so let me just highlight this thing with this nan values, and this is also should be highlighted with this, and this is also this. Okay, fine. So we have seen why we are not getting division by zero error and what is the nan values. Now the next thing is that the integer overflow. So suppose let me explain this thing again. Okay, from here. So integer overflow, what you mean by that? So before doing that, I will just create the numpy array again, np.array, and I'll try to use 1, 10, 20 and 130, and I will give the data type equals to np.integer 8. It means it's a 8-bit integer. Okay, so now if I create this thing, okay, it's created. So if I print this thing, what is supposed to be print? 1, 10, 20, 130, right? This is normal, but I can tell you for this 130 the value will be not 130, something else. Now I'll tell you why. So the size of our integer is integer 8-bit. So now see here, 8-bit integer can store number, cause this is a signed integer, minus 128 to 127. Okay, so it can only store from minus 28 to 127, but what we are trying to store here, we are trying to store 130. So this is actually out of this upper bound, so it will go here, means 127, then 1 minus 128, then minus again this side minus 128, then again minus 127, and then minus 126. So it is going to print minus 126. And how I get this thing? Well, this is the formula, minus 2 to the power n minus 1 to 2 to the power n minus 1 minus 1. It means it is going to be minus 2 to the power n minus 1 is 128. If you do 2 to the power 8 in calculator, you will get this thing. So let me just re-verify this thing for you. So 2 to the power n minus 1 means 2 to the power 7 for 8-bit integers. So let me write 2 to the power 7, see 128, so minus 128, and here it will be 2 to the power n minus 1 means again 2 to the power 7 means 128 minus 1, so it is 127. So it can only save or will be able to store numbers between minus 128 to 127. So whatever you are trying to put after 127, it will become this side. Okay, so in computational mathematics, or in what do you say, in computer architecture organization, those are coming from computer science background, for them it is more or less easier to understand, but those are already working or already forgot everything from their school or college days, for them it will be difficult to remember those stuff. So that is why I put this thing, this formula over here, but don't worry guys, we all knew this concept from our college or school days. Okay, so just try to remember this. And for 16-bit integer, I can get the same thing. So for 32-bit, you can apply the same logic and you can get this thing. So whenever you are trying to save an integer or values which is beyond the upper bound limit, then that time it will come from right hand side to left hand side in the negative side. So that is known as an integer overflow. And if you want to know more about the integer overflow, just go to Wikipedia and Google. You will get much more details on it. But why I am doing this thing? So often in Numpy you are going to or in data science project, you are often required to save or store big numbers. So you have to remember what is your computer architecture and what type of data you are going to be used. Suppose you are dealing with very small data structure and their numbers are going to be deal with 1 and between 1 and 2. Okay, so that time you are not going to use unnecessarily 64 integer. It is not advisable. If you are using your own personal computer, that is fine, but you have to think about from the enterprise point of view. There multiple cluster will be run and your data will not be coming as a separate CSV file. You have to build your data pipeline. You have to use some sort of Spark algorithm to get unstructured or semi-structured data into structured data, and that time this small thing you need to like maintain or need to consider for performance issues. Okay, so if you are using integer 8 or 16 or 32, you have to remember your size of the bounding of your integer. So this is purely mathematical and intuition things. If you are not clear about this concept from your basics or the basics of Numpy, you will not be able to become a good programming guy in machine learning or data science. So that is why I'm doing this thing for all the beginners. Definitely now you are thinking that, oh, okay, it is very complex, I will not be able to understand. No, that is not like that. If you are doing proper practice, you will become champion one day, but you have to do proper practice every day. Okay, so now let's run this thing now. See, it is printed 126 as I told you. 130 means 120. It is going to have until 127. So 130 we are trying to put. It will be 128, 129, 130. So ultimately it will become this side. So 128 become minus 128. Then it will be minus 127 and this will become minus 126. So that is why it is getting printed 126. So hope you guys understand this concept as well. So what I'll do now, I will try to integer overflow here. So let me, okay, so let me delete this thing. Okay, so I'll try to put everything in my GitHub repository, don't worry, but it is already saved, I don't need to save. But before driving towards the end of the video, I would like to recap everything. So in the first tutorial or the first slide, we have seen why you are not getting division by zero errors. It is designed in that way because ultimately this is scientific library in Python, so more or less division by zero means infinite. So that is why it is same as it is like from the mathematical theory, but in most of the programming language you are getting division by zero errors, but Python Numpy it is not happening like that way. But if you see in normal Python array or Python number also we are getting division by zero error, but in Numpy array you are not getting this error, just because the Numpy library has been written completely in C, and they have some special feature, and they actually, while developing this library, they just consider all the mathematical or scientific operation, because ultimately we are going to deal with the numbers and big numbers, small numbers or complex number, whatever, because this is mostly used in all sort of scientific operations. So that is why we are getting infinite. Okay, so next thing is Nan. Nan is again one of the most unique things. If you ask or if you go to any programming means data science block, you often see the first task is to clean up your data. So while doing the cleanup, you need to find what are the missing values. If you are getting missing values, you need to there are multiple things. Either you should not consider those data sets, or if you are considering those data set, you have to just put some values, average value, mean, median values in that Nan value. Suppose you are having 10 records, and out of that 10 records, one record is not having any value, and if then what you will do, you will take the 9 records for which the value is present, and after that you can took the most common values or average value, mean, median values, and you do it. So this is one type of thing. So until and unless you do not know what are the Nan values or what are the missing values are there, it will not be easier for you to clean up or prepare some sort of symmetry within your data. Okay, so that is why Nan value is very important. So it is purely related to the machine learning or data science thing, and trust me guys, you will have to deal with this Nan values very frequently in your data science project in future. So what does it mean? It means undefined, not equal to anything, even not equal to Nan. We have seen this thing, and how to find this Nan values, whether some value is Nan or not, using this thing. and if you do np.isNan equals to np.isNan, then also it is going to return false, cause two nan values cannot be unique. So two nan values could be anything. Nan means could be anything, undefined, so undefined cannot be equals to another undefined. So that is why np.isNan is equals to np.isNan is false. And then integer overflow. So let me do this thing, and we have seen this thing. So when we are going to store n-bit integer, then you have to remember this or you have to consider this formula, because numpy is not protected by this thing as well. Because if you are dealing with 8-bit integer, so you can ultimately store the numbers between -28 to 127. If you are trying to store something, again I'm using the wrong window. If you are trying to open, sorry, if you are trying to save something 130 which is beyond 128, the upper bound or upper limit, then you will get the numbers to left hand side, I mean in the negative side. Okay, so that is called integer overflow. This is also very unique thing. So probably when you are going to deal with millions of data, and sometimes some of the data are probably out of the range, so that time you often get this negative value, and you don't have the time to think about those things, because you want to, your ultimate goal is to run the algorithm or build up the model. But that time probably if you use, or if you do not know what are the values are going to come, your result will be completely different. So, and definitely it will impact your estimation. So that is why these things are very important. So probably you guys are thinking, okay, it's a very simple thing we need to remember. No, this is not like that. These small things are going to make your model efficient. Model means, suppose you need to predict some values. If you are not clear about your concept, you are not clear about your data, if you are not properly doing the data cleanup, so you will definitely able to predict, but your prediction will be not accurate. Okay, probably there could be 10%, 20%, or even 50% margin will be there. The more accurate value you can predict, the more like efficient model you are building. That is the outcome. Okay, so enough of talking, guys. So we'll see you in the next video. Till then, try to do some sort of practice. We have already completed 4th tutorial. This is the 4th tutorial. Enough of like components we talk about from the numpy point of view. Enough of material. Till now we have our side, 4 slides, 4 piece of code, multiple scenarios. So I think this is weekend, and this weekend you guys can have fun with numpy. So we'll see you in the next video. Till then, take care, goodbye, and don't forget to subscribe our channel, hit the like button, share our videos as well with your family and friends, and those are watching for the first time, please subscribe to our channel as well. And please let us know for some sort of feedback, comments, whether you are liking this video or you want us to improve our quality. We'll try to work on this definitely. And special thanks to each and everyone from our Udemy community. Thanks for purchasing this course. It is actually helping me a lot. It is actually motivating me to create course and contents for all of you guys every day. And as I promised, I am coming up with the next series very soon on the numpy. Probably tomorrow I'll upload the next tutorial. Okay, so we'll see you in the next video. Till then, take care, goodbye, and have a nice